Okay, we'll have a look at October 2012, question 1. The first part asked us to explain TPC, CW and freeboard. TPC, that's the tonnes per centimetre, and that's the amount of cargo required to change the draft of the vessel by 1 centimetre. So it's the amount you would load or discharge to change the draft of your vessel by 1 centimetre. And if we look at the hydrostatic particulars, TPC will be dependent upon the density of the water and the draft of the vessel. So when you look at the values, the different values, you can see how it changes with density and with draft. So it would be worth mentioning those two facts as well in this answer. The CW, or water plane coefficient, on your formula sheet you have a formula for CW. You could write that down for this answer, but also you can make a brief sketch to show that it's the water plane coefficient is the ratio between the rectangular shape of a box-shaped vessel and the actual ship shape of the vessel. So if we were to write it as a formula, CW would be the ship shape divided by the box shape, or CW times the box shape would be your ship shape water plane area. You could call it as a percentage of the box shape, and the maximum value of the percent would be 1, or the value would be 1, because if the vessel was indeed a box shape. There are no units, and for example, if CW was 0.89, that would mean that 89% of this rectangular area would represent the vessel's water plane area. So water plane coefficient, it's a way of calculating the water plane area of the vessel. Part 3, freeboard. Well, freeboard is the vertical distance from the deck line to the water line, and of course the deck line is the uppermost continuous watertight deck. So it's the vertical distance down from the uppermost continuous watertight deck or deck line down to the water line. Part B, we're using hydrostatic particulars and we need to calculate 3 different calculations. First one, we arrive in salt water, even keel 5.6, calculate how much cargo can be loaded if we're going to sail at 6 metres. So all we do, we go to the saltwater values, we look up the two drafts, 5.6 and 6.0, write them both down, as I have done here, subtract one from the other, and you'll find that it's 895 tonnes is the answer. Part B, a ship displaces 12217 in fresh water now. We discharge 1,200 tonnes of cargo and we need to calculate the final draft in fresh water. And notice in this question it asks you to use only the displacement and draft values, so you're not using TPC in these. So 12217 minus 1,200, our final displacement 11,017. If we're going to the freshwater values and find our displacements either side of the 11,017, and we'll find at 5.5 it's 10,908, 5.6 is 11,124, our value is 11,017, so we interpolate between them. Whichever way you feel comfortable doing the interpolation, I just write here x over 0.1, which is the difference between these two, is equal to 109, which is 10,908 to 11,017, divided by the difference between the two main values, which is 216. That gives me 0.05, so I know the draft is 5.5 plus the 0.05, because we're going from 5.5 towards 5.6. That gives us a final draft of 5.5. The third one tells us we initially have a saltwater displacement of 12,523, discharge 675 tonnes, calculate the final draft in saltwater, and it does say the appropriate TPC values. So that's in the plural, so it means we're going to be looking at more than one value of TPC. So when we go to our hydrostatic particulars, we get the TPC at 12,523 tonnes, saltwater 22.54. Subtract the 675 tonnes, and that gives us a final displacement of 11,848. We go back in the tables to get the TPC at that value, 22.37, and then all we do is get the mean value. So add the two TPCs together, divide by 2, and our mid TPC is 22.455. So our sinkage is going to be 675 tonnes divided by 22.455, which gives the sink as 0.3 of a metre, excuse me, which is 30 centimetres. Draft initially 6.1, 0.3, gives us a final draft of 5.8. Although I've put sinkage there, of course it's a rise because we've discharged the cargo. And incidentally, if you look at the 11848 in the hydrostatic particulars, it is indeed 5.8 metres draft. So that's how you would do the first question.